Welcome back to Low Stress Math with Mrs. Bono. We are on Book 2, Chapter 4, Solving Systems of Equations, Lesson 9, Using Systems of Equations to Solve Real-World Problems Your Favorite Way, algebraically. All right. Example 1. 700 tickets were sold for the carnival for a total amount of $5,500. Ooh, that's good. An adult ticket cost $10 and a child's ticket cost $5. Find the number of adult tickets and the number of children's tickets sold. Define the two variables you're using. Well, how do I know what variables I'm using? It says, find the number of adult tickets and the number of children's tickets. What I'm looking for is going to be my variables. So if I'm looking for adult tickets, then X equals adult tickets. And I'm looking for children's tickets, so I'm going to make Y children's tickets. I should put adult tickets? No, children's? I don't know, it feels possessive, doesn't it? Adults, tickets, children's tickets. Yeah, that's possessive. Let's make that possessive. T-I-C-K-E-T-S. All right, so create two equations that express the information in the problem. Well, there were 700 tickets sold. 700 tickets. What kind of tickets? Well, obviously, adult tickets and children's tickets. Together are 700 tickets. And the total amount of money? Well, it was $10 for adult tickets plus $5 for children's tickets for a total of $5,500. Now, since neither variable eliminates, you have to multiply one of the equations by a constant. Okay, so I'm going to keep this equation, 10x plus 5y equals 5,500. And I'm going to eliminate the smaller number. I'm going to get rid of the 5y. How do I do that? Well, I have to multiply the top equation times negative 5. So this whole equation is going to be multiplied by negative 5. Negative 5 times 5x, negative 5x. Negative 5 times y, negative 5y. Negative 5 times 700, negative 2,100. So that's how I am eliminating one of my numbers. Okay, now add the equations vertically. I can do that. 10x minus 5x is 5x. 5y minus 5y is 0. And 5,500 minus 2,100 is, did I multiply that right? No, I didn't. Oh my goodness gracious me, where is my whiteout? You guys didn't even stop me when I made that mistake. Must be Monday morning. Must have been up late last night yelling at a television about some silly football game. All right, 5 times 7 is 35. That's better. So now I have to subtract 3,500. And 5,500 minus 3,500 is 2,000. All right, that's a little bit better. Okay. Solve the equation for the remaining variable. All right, let's do that. 5x equals 2,000. Divide both sides by 5. And x equals 5 goes into 24 times, 2 zeros left over. Adult tickets, 400. All right, now I'm going to have to go back and find the children's tickets. So pick an equation from step 2. I'm going to take the easy one. X plus y equals 700. And I'll substitute 400 for x. 400 plus y is 700. And I have to subtract 400 from both sides to get y equals 300. So now I know x and y, but that doesn't really mean anything unless I go back and write myself a sentence saying 400 what? 300 what? I have to answer the equation. So I have to answer the problem, and the problem was Find the number of adult tickets and the number of children's tickets sold. So, here's my solution. 400 adult tickets, 400 adult tickets, and 300 children's tickets were sold. I almost made that one word. Children, that is one word. Sorry about that, guys, got a little sloppy. Children's tickets were sold. All right, let's try another problem. Example 2. A bank teller is counting $20 bills and $10 bills. There are 16 bills. That's a total of $200. Write and solve a system of equations to find the number x of $20 bills and the number y of $10 bills. Well, they made the first step for me easy, where it says define the variables, because it told me that x equals the number of $20 bills, which means y equals the number of $10 bills. So I have to create two equations that express the given information. Well, the first bit of information I have is that there are 16 bills altogether. So the $20 bills plus the $10 bills, y, is going to be equal to 16 bills. Now I have to find out how much they're worth. So 20 times the number of $20 bills plus 10 times the number of $10 bills is going to equal a total of $200. All right, now let's solve that. I'm going to keep this and I'm going to multiply times -10. I want to get rid of the $10 bills, so I'll find the $20 bills first. So 20x plus 10y equals 200. To get rid of the 10y, I have to have a negative 10y. So I'll go back up here and I will multiply times -10. -10 times x, -10x, -10 times y, -10y, -10 times 16, -160. All right, now combine vertically. 20 minus 10, 10x. 10 minus 10, 0. 200 minus 160 is 40. Divide both sides by 10. And x equals 4. What does that mean? That means there's 4 $20 bills. That's what that means. So now I have to go back and find the number of $10 bills. So x plus y equals 16. 4 $20 bills plus some $10 bills equals 16 bills. Minus 4 from both sides. And y equals 12. So there's 12 $10 bills and 4 $20 bills. Now I have to write that down here. Now when I write it in a sentence, hear me out. They told me $20 bills, and the way they wrote it was $20 and bills. So I'm going to write 4 as the number 4, F-O-U-R, because I want it to be as easy to read for the elderly person grading it as possible. So there are 4 $20 bills and 12 $10 bills. It's easy to read. You don't get confused between the amount of money and the number of bills. That's a good way to do it. All right, let's take a look at the checkpoint. Yay, pause the video. Do the checkpoint. You can do it. All right, pause this video. Get her done. Pause the video. You can't learn math unless you do math. Do this. All right. Morgan bought 7 pairs of wool and cotton socks. That's 2 different objects. That's going to be my X and Y. She bought wool socks that cost $3 per pair and cotton socks that cost $2 per pair. And she spent $18 altogether. So let X equal wool socks, Y equals cotton socks, and let's write an equation. The number of wool socks plus the number of cotton socks equals 7 pairs. And how much were wool socks? $3. I wish wool socks were $3. Plus $2 for the cotton socks. And that's going to equal $18 altogether. So there's my 2 equations. I'm going to eliminate the Y. It doesn't matter which one you eliminate, by the way. It'll come out to be the same, but we'll multiply this one times -2. And I'm keeping this bottom equation. So 3x plus 2y equals 18. -2 times x is -2x. -2 times y minus 2y equals -2 times 7, -14. All right, now I have to combine them vertically. 3x minus 2x is just x. 2y minus 2y is 0, and 18 minus 14 is 4. Okay, so now I know there's 4 pairs of wool socks. So x plus y equals 7. 4 plus y equals 7, minus the 4 on both sides, and y equals 3. So there's 3 pairs of cotton socks. Write a sentence to determine how many pairs of each type of sock she bought. Well, Morgan bought 4 pairs of woolly socks and 3 pairs of cotton socks. Not horrible. I think you can do this. All right, let's take a look at the next page. Dun, 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 dun. All right. One car model costs $1,200, and the average of 10 cents per mile. Ugh. Remember, this word means per. That's where the variable is going to go. Another car costs $1,400, an average of, here's that per again. That's going to be my X to maintain. If each of the models is driven the same number of miles, how many miles would the total cost, that's another thing, be the same? So X is the miles. How do I know? Because it's per mile. X equals miles. So Y is going to be the total cost. And why am I writing in red? I have no idea. All right, create 2 equations to form a system of equations to express the given information. All right, let's look at car 1. Let's give it a fancy name. Yeah, we'll call it first car. First car. And the total cost for the first car is going to be this $12,000 plus 10 cents per mile. And the second car, that other fancy name, is going to be a total cost of $1,400 plus 8 cents per mile. All right. Now, those are both equal to Y. What does that mean? When they're both equal to the same variable, they're equal to each other. So, let's see. 12,000, oof, plus 10 cents per mile, put the decimal in the right spot, is going to be equal to 14,000 plus 8 cents per mile. And here's the line. To get from one side to the other, you have to subtract. So I'm going to subtract the x first. I'm going to move the smaller variable to the larger variable. And yes, 8 cents is smaller than 10 cents. Come on, guys, you know that. And now I have 12,000 plus 0.02x equals 1,400. I keep saying 100 when I mean 1,000. My apologies. 14,000. So let's finish this off. Let's subtract 12,000 from both sides. And I get 2 cents x equals 2,000. And I divide both sides by 0.02. How much money am I going to have? I don't know. I do know, but I'm going to do it on the calculator anyhow. All right. 2,000 divided by 0.02 is 100,000. That means at 100,000 miles, they will be exactly the same cost. So x equals 100,000 miles. And my sentence would be, at 100,000 miles, the total cost is the same. All right, guys, next 2 pages are homework, 125 and 126. I'll talk to you soon. Bye.